Alright, so these are going to be our notes on rocks. You've already been talking about, actually, wrong thing there. I guess that's good. You've already been talking about minerals. Let me clear this off. And the next step is to take those minerals and put them together to form a mixture that are called rocks. And these are all tied together. Like we started looking at matter, and we said matter is made up of the basic unit, an atom. And then atoms come together and they form, if it's the same atoms, they form elements, like on the periodic table. If they're different, they form compounds. Then those elements and those compounds come together and they form mixtures. Well, an example of a mixture, one of the examples of a mixture is a rock. So a mixture. So you pick a rock up, it's made up of all these different types of minerals. Some are just a few, but many are composed of many different types of minerals. And the basic characteristics of a rock is it's solid, it's non-living, which means inorganic. And then two or more minerals. So we're just expanding this idea of a mixture. There are really three basic types of rocks: igneous, sedimentary, and metamorphic. And you've probably been exposed to these if you've been at Kenny Lake School through middle school, and I'm kind of go through this fast, and I'm thinking some of this information you remember. At least I hope you do. But the main definition of an igneous rock is something formed from a melt. So like inside the earth, so if you had the earth here, and we have the crust, really thin, almost like if you think of an apple, the skin of an apple, that's how big the crust is in comparison to everything else inside the earth. Well, you have the crust, and this is a solid, and this is just rock that's been hardened. But then inside here you have something called the mantle. And inside that mantle is some material that's like semi-solid, like a mixture between a solid and a liquid. And then you also have, within the mantle, you have liquid as well. And then you get to the center. The core is made up of iron, and there's all these pressure things going on because of the extreme pressure that exists inside the earth. But inside here it's really hot, super hot, and this just melts the rock and forms something we call magma. I'm going to go back on that one. Magma. And magma is just hot molten rock inside the earth, or below the surface, or within the crust. When this magma then comes out through a volcano, whatever it is, and is found on the surface of the earth, and you kind of know this already, but I'm just telling you anyway, it's called lava. So once it comes out here, it's lava. It's just talking about location. And then magma inside the earth. And then, so these igneous rock, they form from a melt. So somehow, material that was a solid is melted, and then it cools. So it's melted, and then it cools. I'll actually do blue here. So it cools. And it forms a solid. So this is the liquid. It then cools and it forms a solid. And depending on how fast it cools, it forms large crystals or small crystals. And we call really two different types of igneous rock. One is intrusive and the other one is extrusive. And it's intrusive means it's inside the earth. So these kind of rocks are formed inside the earth. And because they cool inside the earth, they cool much slower, and that allows these crystals time to form. So then they have these very large crystals that are really easy to see, and you'll see that in some videos that we watch. And then, but extrusive rocks like in lava, so these would be magma, right? You see that right here, magma. But then Extrusive are the ones that just get shot out through a volcano on the surface of the Earth, and they're exposed to the surface of the Earth, so they cool really quick. And because they cool really quick, there's no time for these crystals to form, so they're very small and you can't see them. These kind of rocks too, also, they tend to be, they don't have to be now, but they tend to be one color if you see them. Now, one color, and then they have crystals in them that give them maybe a different color. But in general, they're just one big solid color that dominates. So those are the two. Intrusive form inside the Earth, extrusive form outside the Earth. So we'll go to the next, I'm going to erase here. Go to the next type of rock. And this is sedimentary rock. So sedimentary rock, a little bit different. And this is really the main type of rock we even see. Now we live in a place that's kind of interesting because where we live, there's not a lot of these sedimentary rocks. Most places there are. Most places are just dominated by this rock. But where we live is very unique because in the Copper River Valley, we have lots of glaciers, right? We kind of learned about these. And because we have all these glaciers have come through and they've scraped all these sedimentary rocks off, and then the runoff and once the ice melts and they recede, all those sedimentary rocks get carried somewhere else. And so we don't see a lot of them. So we have a lot of igneous rock. If you pick up a rock where we live, it's going to probably be an igneous rock. You could find a sedimentary, not as likely. But sedimentary rocks sedimentary are the next type of rock, and these are formed in different ways. There's really three types: clastic, chemical, and organic. Now these are usually formed on the surface of the Earth. And they form layers, they form in layers, and they also form from other types of rocks. And I don't think that this is the only type, because igneous, if a sedimentary rock gets melted, and turned into magma or lava, then it can form a new type of rock and be recycled. But sedimentary rock, really, on the surface of the Earth, you have igneous rock and other sedimentary rocks and metamorphic rocks, which is our last type, and then they, through a process, weathering and erosion, can form a clastic rock, or through the process of chemical reactions can form a chemical rock, chemical sedimentary rock, or living things can also leave their remains behind and form sedimentary rocks as well. So the three types here you see: clastic, and these are formed through the weathering and erosion process we kind of learned about already. So rock pieces get broken down, they get carried somewhere else by wind, water, and so on, glaciers, and then they get deposited in a new place where these small little pieces, sometimes they're bigger, they can be really large actually, and they form these new layers, and that forms a clastic sedimentary rock. Now chemical sedimentary rocks can be a little different. They can be particles are carried in the rock, chemical reactions take place, form something new, and then the water is evaporated away and they leave these layering of materials behind. Okay, that's a chemical sedimentary rock. And then organic is the last type, and we'll make this green actually. See if I can find a green one, because it's organic, it's living. And then so these are the remains of living things, a lot of times like shells is a really good example. A lot of organisms have shells and coverings that protect them. When these organisms die, they leave these behind, and these can be dissolved in water, they can be left just on the surface of the Earth. They form layers just like this clastic sedimentary rock, but then they're formed from sediments. These are formed from the remains of living things. A really good example of this are plants. Plants were living things. They get buried a certain way under a certain amount of pressure, and they can form coal and byproducts. So we got coal here that we can use to produce energy. We can also get natural gas, NG, and we can get oil. All these kind of work together, just depends on the processes. So any of these are possible. And these would be organic sedimentary rocks. So the last type here, I'm going to erase this, is metamorphic. I'm going to move this down. Metamorphic rocks are those formed due to heat and pressure. And they generally form in very specific places. One of the most common places to find them are at plate boundaries. Okay, so because they have just the right conditions. When you have a boundary, one plate is pushing on another, maybe one sliding underneath the other, a subduction zone, and this one's going this way, this one's going this way, and there's a lot of pressure right here. A lot of pressure. And that can cause a metamorphic rock to form. The other thing you need, though, is heat. So you might have some magma that's working its way up through the surface here. So down here, you have some magma that works up, and at the same time that this subduction zone is happening, one plate is going underneath another, this magma works its way up into here, and at just the right time you get the right amount of pressure, the right amount of heat, and you get a metamorphic rock. And these have to be just right, though. If you get too much heating, you then melt it and you form a igneous rock. You're going to get enough heat, no melting is needed. If you melt it, it's done. It's not a metamorphic rock anymore. It doesn't matter the pressure. So it has to be heated just right, not too much, not too little. It's just right, kind of like a Goldilocks rock. So it's just right. So, and this also can be formed. So if this is the crust here, this is can be an igneous rock or sedimentary rock, and they come together, they get forced together, they form metamorphic rocks. A really common mountain chain that's one around us is the Chugach Mountains, the one that we find all around us. If you go down the Edgerton Highway, like down near the Tonsina, like here's the road, going down. Okay, and over on this side you have the Wrangels, right? Mount Drum, we'll put Drum over here, or Wrangell, Drum, Blackburn, all these kind of mountains. These are igneous. They're volcanic. You might not have known this before, so I'm going to tell you this. But these are igneous. These are igneous mountains. They're igneous rock. But on the other side, a little bit less mountains, and these mountains work their way into Valdez. They run right alongside the road there. There's like a boundary right there. These are the Chugach Mountains, and these here are the Wrangels. The Chugach I was going to show you are on the other side of the road, and they're metamorphic. So you had something happen here where there was a plate boundary at one time or something, and these mountains were metamorphic. So if you're driving down this road, you look one way, those are igneous rocks. You look the other, they're metamorphic. Okay. So if I get rid of that, so tectonic activity, mountain building, and just the right amount of heat. The last thing I want to talk about is the rock cycle. So the rock cycle is the idea that there's a continuous recycling of one rock into another, or back into a different type of rock. So you can have an igneous rock, and if it gets broken down by weathering and erosion, it can form a sedimentary rock. But then if it gets melted, it can form back into an igneous rock. If it then doesn't get quite melted, but has enough heat and pressure, it can form a metamorphic rock. And then if it gets melted, it forms an igneous rock again. This igneous rock, it gets melted, it forms another igneous rock, sedimentary, and so on. So even the metamorphic rock, they can get weathered and eroded, and they can form a sedimentary rock. So this is a continuous process where one rock forms another, and then even metamorphic rock can get changed into a different type of metamorphic rock. It's really an interesting process. It's something that has been going on for thousands of years and continues today. So I hope these notes helped you understand this, give you kind of a brush up on the types of rocks and the rock cycle. Make sure you annotate your notes and show them to me so I know that you watched them. And have a good night.